Hey guys, this is a video about vessels. So we're specifically going to be talking about arteries, veins, and capillaries. So I just want you to pause and take a moment to read your understandings. You're reading 6.2.1 to 6.2.6 right now, and just kind of get your mind in the right place and get ready to learn these topics. Okay, so we're going to start by discussing veins and arteries. These are the major blood vessels in the body. They're also the most visible blood vessels in the body, and they serve two different purposes. Now, we already talked in class about the fact that arteries carry blood away from the heart, and veins carry blood to the heart. But in order to do this, each of these vessels has to have some really specific physical characteristics. So let's start with arteries. Arteries are made to move pressurized blood away from the heart. And so when the blood is in an artery, it's at its highest possible pressure because it was just pumped by the heart. And so it was sent out quickly and at a high pressure, usually somewhere between 10 and 16 kilopascals. So because of this high pressure environment and this high pressure that's developed by the heart, arteries have to have a few characteristics. Number one, they need to have a thick muscular wall that's capable of constriction. Okay, so not only does the artery need to be muscular in order to prevent tearing, but they also need to be capable of constriction in order to maintain that high pressure. Number two, they have a large amount of elastic fiber, so they're somewhat flexible, again, to resist any type of tearing. Number three, the lumen, or the inside, and let me mark it here, the lumen of the artery actually has a really small diameter, and again, that is to just help to maintain that high pressure, keep that space small to keep the pressure high. And lastly, the artery is not permeable. So when blood is in the arteries, this is not the time when nutrients and water and things are flowing out to the tissues or waste are flowing back from the tissues. This is simply a method of transport. Okay, so then we're going to move on to the vein. The veins are made, they have a little bit different structure. When blood is headed back to the heart, it has lost a lot of that gusto, a lot of that pressure that it had first leaving the heart. And so veins carry blood that is at very low pressure, usually around 1 kilopascal. So remember, arteries carried 10 to 16 kilopascals. Veins carry 1 kilopascal, so much, much lower pressure. The veins have a very thin muscular wall, and they have a very large lumen, or internal diameter. This is so that a greater volume of blood can flow in order to make up, it's moving more slowly, so this is to make up for the smaller volume of blood that is flowing quickly from the arteries. So this keeps the system balanced. If a little bit of blood is flowing quickly in the arteries and a lot of blood is moving slowly in the veins, it keeps that balance. Okay, so they have a thin muscular wall with a large diameter. Number two, they have very little elastic fiber. There's very little need or opportunity for veins to be stretched. In addition, they are not permeable either. So veins are, again, just used to transport blood, not to diffuse nutrients and gases. And then lastly, they contain valves, as you can see here. They contain valves that prevent backflow. Remember that this is a closed circuit system and it is unidirectional, so blood always needs to be moving in the same direction at all times. So blood in the veins does move slowly, but efficiently it makes its way back to the heart. And in class we are going to be taking a look at mammalian arteries and veins to actually look at a comparison of these different tissues. Okay, our last type of vessel that we need to discuss is called a capillary, and capillaries are kind of where the magic happens. So capillaries link arteries and veins. So as you can see here on this capillary, we've got our artery coming in and our vein going out. Okay, so capillaries branch off the arteries, they branch off the veins, and they are the part of this system that does deliver gases, delivers nutrients, takes away waste, etc. Okay, so capillaries are incredibly numerous. It's not even known how many are in the body or how long if you laid them all out, but they're incredibly numerous. And usually when you get a cut or something like that that's superficial, you are cutting your capillaries. So the characteristics of capillaries are that they have no muscle, okay? They have no elastic tissue because again, the blood is not flowing through at super high pressures once it hits the capillaries, but they have no muscle tissue, no elastic tissue, no valves. They're super, super simple. And the wall of a capillary is only one cell layer thick. And so this makes it the perfect tissue to deliver nutrients, gases, etc. to the body tissues because they don't have to diffuse very far. Okay, so these capillaries are just interlaced in all of our different organs, all of our different tissues, and it is the way that things get transported from the blood system out to the body. Okay, the last thing we need to talk about is actually coronary heart disease. This is one of the examples that IB has asked us to discuss in relation to the vessels. And so we're going to talk about coronary heart disease. And first we need to think back to our heart diagram. So the main artery leaving the heart, remember, is the aorta. And the aorta has 3 major branches that come off it almost immediately. And some of the arteries off of these branches actually go back to supply the heart muscle. So they're attached to the outside of the heart, and they're supplying the heart muscle itself with nutrients, with gases, etc. Okay, so someone who has coronary heart disease, what's happening is that, these arteries become blocked for some reason. Maybe they've been damaged, maybe there's been a big plaque built up, maybe a blood clot forms. Okay, there's a lot of different reasons that this could happen. But what the result is that the heart tissue itself begins to die, and then it will stop contracting. And this will then lead to a heart attack. Okay, so if the heart muscle itself isn't being supplied with blood, and keep in mind it can't be supplied with blood that's in the atrium or the ventricle, okay, so it needs to be supplied by these vessels because the walls of the atria and ventricles are not permeable. So it needs to be supplied by these vessels, and if it's not, then it can lead to a heart attack. So one common cause of coronary heart disease is called atherosclerosis, and I'll spell that for you. It's ATHEROSCLEROSIS. And this is a slow degeneration of the artery lining, causing a buildup of plaque, which we see here. That plaque will then restrict the flow. You see how it makes the volume of the lumen a lot smaller. And any type of major stress could cause an additional injury to the artery, causing a blood clot, which would then fully block this artery, blocking flow of blood to the heart muscle, and in turn causing a heart attack. So that is coronary heart disease, and that is one way that our vessels are super important for supplying different tissues. And please write down any questions you have. We are going to be doing that artery and vein lab soon. And let me know what you've thought of when we get back to class. Thanks.